Good morning to all of you. Today we are going to discuss about Fresnel's diffraction and half period zone. So let's start. So in case of Fresnel diffraction, or in this class of diffraction, the source or screen or both are at finite distance from the diffracting aperture. Here diffracting aperture means slit. If the slit is either be nearer to the source, or that means slit has to be a finite distance either to the source or screen. So if we are going to discuss about our previous classes, suppose we have to consider the Fraunhofer diffraction. In this case, the source and slit both are at the infinite distance which corresponds to the aperture. Aperture means the so-called slit. So these are the double slit. So from the double slit, the both screen and the source are at infinite distance, or we can say the large distance. But in case of this Fresnel diffraction, either you can say either your source, and suppose this is your aperture, or slit you can say, and this is your screen. So either source is finite distance to the slit or aperture, or screen is at the finite distance of the slit, or both source and screen at a finite distance, not at the infinite distance. This is the first experimental arrangement, we can say, or of the Fresnel's diffraction. Now again, the Fresnel diffraction pattern are based on the Fresnel's hygiene principle. So first we have to somewhat recap the hygiene's principle. May you have been remembered one thing, that in case of hygiene's principle, from the primary wavefront we can get other secondary wavefronts. So this AB is called as the primary source or primary wavefront. Supposed to be the source will be here. Okay, the source will be here and it is sending the wavefronts. So if we are going to consider that AB is a wavefront, then on the wavefront each and every point will be act as a source. This point A, small a, this point small b, C, D. So each and every point will be act as another source, can be send their wavefronts. Due to that, we can get another wavefront like this, which will be called as secondary wavefront. So if we are going to add all of these wavefronts, then this will be the another wavefront. So this we have been discussed. Okay, so A dash B dash, this A dash B dash wavefront is called as the secondary wavefront. Okay, which is created by the secondary source where they are on the primary wavefront. Okay, so this is all about our Hygiene's principle. So Fresnel also considered this principle and used in his theory. So only for that it is written that Fresnel's Hygiene's principle or theory. Okay, according to this principle, what happened? Each point on the wavefront is a source of secondary disturbance. What we have been discussed. Each point on the wavefront, that means this wavefront, that means it is a primary wavefront, is a secondary disturbance, and secondary wavelets originating from the different points interferes with each other, producing patterns to observe intensity. So whatever, so we can say that from this primary wavefront we found number of sources. These points are called as sources from which the waves are propagating, due to which we got the secondary wavefront, that is A dash B dash. So if we are going to consider this is a source, 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 or we can consider that this is a slit, this is a slit, this is another slit, this is another slit, this is another slit. So if we are going to consider on the primary wavefront, these are the slits from which light is passing like this. So we are going to consider, imagine this one, light is passing like this, and if it will be diffracted and superimposed with each other on the screen at somewhere on the screen, then we can found the so-called interference pattern. That means if we have to consider this ray and this ray from this source and this source at this point, suppose they are moving like this, we are going to consider a point here. So from this the source is the light is gone like this, from this it has to go like this. From this source the light has to travel in this path for creating the diffraction pattern. Like that, at a point we can get the diffraction pattern due to the interference of these different sources which is originating or which is creating on the primary wavefront like this. Okay, this is the considerations of the Fresnel, by the Fresnel, and only for that it is called the Fresnel Hygiene principle. And this, due to this source secondary disturbance and secondary wavelets outgoing originating from the different points interfere with each other, producing patterns. So here it is written that originating from the different points, here different points of the primary wavefront. You have to just somewhat correct here. Originating from the different points of primary wavefront. Okay, interferes with each other and producing the interference pattern. To observe the intensity of the diffracted wave at any point on the screen, Fresnel made some assumptions known as Fresnel's assumption. So Fresnel's assumptions are what? The incident wave front on a slit divide into number of strips. These strips are known as zones, called as Fresnel's zones. The resultant intensity at any point of the screen is combined effect of light energy coming from that different zones. The intensity at any point on the screen depends on the distance between the point and the chosen zone. So here we can see that this is the wavefront which is interacted. This is the wavefront interacted with the slit AB, and from this the light is passed and we can observe the so-called diffraction pattern on the screen. So what the Fresnel assumed, that suppose this is the wavefront, this is our A, B, suppose. Okay, so this is our AB wavefront, that whatever we have been discussed, this is A and B. So here whatever the portion it has been interacted, this is the, if this is the primary wavefront, then this point, this point, this point, these all the points can be considered as the secondary sources, or these points according to Hygiene's, these points will be a source, this point will be a source, this point will be a source. So from this assumption he considered that the wavefront can be separated out, or the wavefront can be designed by the zones, which will be called as Fresnel zones, that we are going to discuss in the next page. The intensity at point on the screen depends on the distance between the point and the chosen zone. So suppose at the point P, whatever we here at this point, if you want to find out the diffraction intensity, then what will be the distance? That means from here, suppose this is the zone or the point or the secondary source we have been considered. From this to this, what is the distance? That is the intensity also depends upon this. And the intensity at any point P depends on the obliquity. Obliquity means, suppose we have considered this is the source. From this source, how much angle the P can be observed if we are going to consider this is the origin. From this point, so if we have to consider this is the full slit, okay, then from this slit, if light is passed, so this is the normal path, this is the light's normal path, so this is O on the screen. So how much angle created by this point with a secondary source, that also is going to be considered. That is called as the obliquity. That is the obliquity. So here this obliquity factor is written by a equation that will be called as or the intensity is going to be, so the intensity due to obliquity factor, if we are going to consider the intensity at point P, is calculated by this formula, that is I0 into 1 plus cos theta, where is the theta is the angle between the point and the angle between the point and the slit. Okay, so if this angle is 90 degree, that means the point is if farther from this slit, then what will happen? 90 degree cos 90 degree will be equal to 0, then this value will be equal to 0, and the intensity will be minimum, that will be I0 we can get. The intensity only I0 we can get for theta equal to 90 degree. So here you can write another sentence, when theta equal to 90 degree, then I equal to I0. But if theta equal to 0, then I equal to 2I0, which will be maximum. So this is the obliquity factor also assumed by the Fresnel, and then he described many things about the diffraction that we are going to be study. Before that, we have to discuss what is called as the half period zone. What will be the called as half period? Now, Fresnel's half period zone for plane wave. Let us consider a ABCD is a plane wavefront. This is A, B, C, D is a plane wavefront, okay, which is perpendicular to the plane of paper like this. So this is the wavefront and it is like this only, okay. That means it is moving along this direction, okay. Now the point P is situated at a distance B perpendicular to ABCD. That means here point P, where we are going to observe the diffraction pattern, which is situated at the distance B from this wavefront. From this wavefront, this point is situated at the point B, and OP is the length is B, whereas OM. Now what Fresnel has been done to find the resultant intensity at point P due to wavefront ABCD. This is the wavefront. Due to wavefront ABCD, to finding the resultant intensity at a point P, Fresnel method consists in dividing the wavefront into number of half period elements or zone called as Fresnel's zone, or also it will be called as Fresnel's half period zone, and to find the effect of all zones at the point. That means this is full wavefront. This is ABCD. This is your ABCD wavefront. This is ABCD. So whenever this wavefront is moving like this, and due to this wavefront, if we want to find out the intensity, diffraction intensity at point P, which is at distance B from this wavefront, Fresnel, what he done? He done that this wavefront is divided into different zones, different circular elements will be called as Fresnel half period zone. That means this circular zone is called as the first half period zone. This circular analog, this is another, is called as the second half period zone, and this one is called as third half period zone, this one is called the fourth half period zone, like that. And the radius of first half period zone is 0 to m1, this one, and radius of second half period zone is 0 O2, sorry, O to m2, O to m3 is the third half period zone, O to m4 is the fourth half period zone radius. Now he has been considered one thing, that the distance from wavefront to P is B, but the distance from here, from the top of the first half period zone, from here to the point, like this, from this to this point is B plus lambda by 2. That means he considered whatever the light is passing from this O is gone normally to the point, and whatever the light is passed through this small portion, or the small portion, that is M1. If I am going to be consider this small circular, its circumference is a slit, very small, very thin. If I am going to be considered like this, wait, okay. So if I am going to consider now, this type of things has been considered. The light is passed through the center like this without any path difference, but if the light is passed through this circular circumference line, the light is passed through this one, from this, not whole this your half period zone, only from this, then that light has the path difference is equal to B plus lambda by 2. Okay. And if we have to consider M2 like that, from M2 to P, the path difference will be from O as compared to the OP, M2 to P will be B plus 2 lambda by 2. From M3 to P, B plus 3 lambda by 2. But the half period zone R is nothing but this area is called the first half period zone, this area is called the second half period zone, like that. So in this page also same thing has been written, with as center P, radius equal to, now with P as the center, the radius equal to B plus lambda by 2, B plus 2 lambda by 2, B plus 3 etc. construct sphere which will be cut out the circular area of the radii OM1, OM2, OM3 etc. Or we can consider like this. See, suppose this is a circular area. This is a circular area like that. Suppose if we have to consider P is the point P, which is the center at this, okay, center, suppose P is the center at the center, and we are going to consider a sphere, then if we have to intersect this sphere to this wavefront, then it will cut like this circular format. If one sphere, see, P is at the center, and if this sphere is going to be cut this wavefront, then we can get a one annulus. Another radius of sphere is going to be cut. We are going to get the another annulus having the radius OM1, OM2 like that. So the first radius of the sphere which is going to be cut the wavefront is nothing but PB plus lambda by 2. Another sphere which will cut the wavefront, and we are going to get the circular annulus OM2 having the radius OM2 is this one B plus 2 lambda by 2 and like that. So circular area of the radius OM1, OM2, OM3 like that on the wavefront, which is shown in the figure 2. These circular zones are called half period zones. These circular zones, this is first half period zone, this is second half period zone. Okay, these are called the half period zones. So each zone differs from each other, differs from its neighbor by phase difference. How much? Na pi. So if we are going to consider one zone to another having the phase difference, how much? Pi. The corresponding path difference will be lambda by 2. Hence the secondary waves starting from O and M1 and reaching the point P have the phase difference will be pi or path difference will be lambda by 2. That means Fresnel accepted that for first zone to second zone whatever the phase difference will be pi. The corresponding path difference is lambda by 2. So if we are going to consider the wave or secondary wave starting from O, from this slit from O to P and from M1 to P, what will be the path difference? That will be B plus lambda by 2 only. B plus lambda by 2 minus B. That is path difference between M1P and OP will be B lambda by 2 minus B will be equal to lambda by 2. Like path difference between the two consecutive secondary waves. That means if we are going to consider path difference between M1P and M2P also lambda by 2. So this is all about Fresnel diffraction, about introduction to Fresnel diffraction and half period zone. Next we have to consider the rectilinear propagation of the light in the next video. Okay.